special type of functions. First, identity function. Let R be the set of real numbers. The real valued function f such the real to real is said to be identity function if y is equal to f of x is equal to x for all x belongs to real number. Domain of f is equal to that is dom of f which is equal to real number, and range of f is equal to real number. Codomain of f is equal to real number. That means here if you put one value that in place of x, y value 1. So if you put 2 value, also got y value 2. That means if you join that value, okay, you form a y is equal to x line that creates angle 45 degree. So that's why here the x is the domain, y is the range. So range is equal to real number and codomain is equal to real number, domain is equal to real number. Now comes to constant function. The real valued function f such that real to real is said to be constant function if y is equal to f of x is equal to k for all x belongs to real number. Means here if you put 0 value it gives k value, 1 value it gives k value, 2 value it gives k value, 3 value it gives k value. So that x you put, you get always k value. That means range of the function is equal to k, domain of the function is equal to real number, and the codomain of the function is equal to real number. Now polynomial function. A function f such that a to r is said to be a polynomial function of degree n if f of x is equal to a0 plus a1x plus a2x square plus dot 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 an x to the power n, where n is a non-negative integer. Non-negative integer, x belongs to real number, then an is not equal to 0. An is not equal to 0. That a0, a1 up to an is belongs to real number. That is 2x plus 3, one example, 1 plus x square, another example, x square minus x plus 2, another example, x fourth plus x, another example. Similarly, x to the power 3 by 2 plus x is not a function because 3 by 2 is not a whole number. So another example if you take function f such the real to real by y is equal to f of x is equal to x square, where x belongs to real number. Now here x value minus 4, that is 60. Here that is minus 3, that is 9. This is minus 2, that is 4. This is minus 1, this is 1. This is 0, this is 0. This is 1, this is 1. This comes here. In the put this value you get, that is like a parabola. So that domain of the function is equal to real number, a range of the function is equal to x square such that x belongs to real number. Codomain of the function is equal to real number. That means here the polynomial function का domain according to the question and okay the range according to the question and codomain according to the question. Here rational function. A function fx such that a to b is said to be rational function if f of x is equal to px by qx, where px qx are polynomial function with qx is not equal to 0. The domain of the f is equal to real minus 0 or according to the question. Now modulus function. Range of the function is equal to according to the question. Codomain is equal to according to question. Now modulus of function. A function f such that real to real is said to be modulus function if y is equal to f of x is equal to modulus of x. Means x if x is greater than 0, 0 if x is equal to 0, minus x if x is less than 0. That means domain of the function is equal to real number, range of the function is equal to real plus union 0. The codomain of the f is equal to real number. That means if you put x, then you get x modulus, that is the y here. Whatever value, negative value always put, that positive comes. Means minus 4 put, that 4 comes. Minus 2 put, that is equal to 2 comes. Similarly, this is the drawing diagram. Okay, that means always it gives a positive value with 0. Now, Signum Function or Signum Function. A function f such that real to real is said to be Signum Function if y is equal to f of x, that is equal to Sgn of x. That means x by x modulus if x is not equal to 0, 0 if x is equal to 0. That means minus 1 if x is less than 0, 0 if x equal to 0, 1 if x is greater than 0. So here put the x, that is f of x is equal to x by modulus of x or modulus of x by x. So domain of f is equal to real number, a range of the f is equal to minus 1, 0, 1. Now codomain of f is equal to real number. Here that is equal to 0 port, it is comes to 0. And 1 port, it comes to 1. If 2 port, it comes to 2. Then whatever the positive value, it comes to 1. Whatever the negative value put, that it comes to, that is minus 1. Now greatest integer function. A function f such that real to real is said to be greatest integer function if y is equal to f of x, which is equal to, that is the greatest integer of x, means x bracket of x. Y is equal to f of x is equal to bracket of x. That is redefined as minus 1 if minus 1 is less than equal to x less than 0. 0 if 0 less than x less than 1. 1 if 1 less than equal to x less than 2. 2 if 2 is less than equal to x less than 3. N if n is less than x less than n plus 1. Means 2.05, that is 2 plus 0.5, which greatest integer is equal to 2. Integer value maximum, that is 2. Here 2.09, that is 2 plus 0.9, that is greatest integer value is equal to 2 here. Minus 3.07, that is minus 4 plus 0.93, which is equal to minus 4. So that's why here the diagram comes, that is equal to, that is the open interval, this is closed, this is open, 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 this is closed. That's why the domain, codomain of the function is equal to real number, range of the function always comes to integer, and domain of the function is equal to real number. So greatest integer function is also called step function or jump function. Now comes to the exponential function. A function f such that r to r plus is said to be exponential function if y is equal to f of x is equal to a to the power x, where a is greater than 0 and a is not equal to 1. Now a to the power x plus y is equal to a to the power x into a to the power y, where a is greater than 0. A to the power x to whole to the power y is equal to a to the power xy, that x comma y is belongs to real number. The a to the power x is equal to 1 if and only if x is equal to 0. Similarly, if a is greater than 1, a to the power x is greater than a to the power y if and only if x is greater than y. Now, if a is less than 1, then a to the power x is greater than a to the power y if x is less than y. A to the power x is closer to the x-axis, means this way. This is the closer to the x-axis, this comes to this way. Means this is a to the power x. That means if a is greater than 1, this diagram. If a is less than 1, this diagram it comes. It passes through, that is 0, 1 always. Here domain of the function is equal to real number and range of the function is equal to real positive and codomain of the function is equal to real number. Here 10 to the power x is a common exponential and e to the power x is a natural exponential. If you put x value, it always comes to a to the power x format. So a is the base, x is the exponent here. Here, whatever the value it comes, that is a value. A value it increases, that's why it comes to the nearer to the y value, y axis. Now, logarithmic function. Here, f shows the real plus 2 real number. The function f defined by fx is equal to log of x base a, where a is greater than 0, comma a is not equal to 1, where y is equal to log of x base a. Means that implies a to the power y is equal to x, which is called logarithmic function. That means here, the domain of the function is equal to real plus, and the range of the function is equal to real. Codomain of the function is equal to real number. Here, if a is less than 1, the diagram comes, it is here, it passes to always 1, comma 0. If a is greater than 1, the diagram looks like this. This is a which closer to y axis, that end passes to 1, comma 0. Here, that is a r plus to r, the x it put, if you export it comes to log x comes. So here the log xy to base a is equal to log x base a plus log y base a. Log x by y base a is equal to log x base a minus log y base a. Log x base a is equal to 0. That implies x is equal to 1. Log x base x is equal to 1. Base and okay same होने से 1 होता है. Log of x base a is equal to 1 by log a base x. X is not equal to 1. Here log x base a is equal to log x base b into log b base a base conversion. If a is greater than 1, log x base a is greater than log y base a, if and only if x is greater than y. If a is less than 1, log x base a is less than log y base a, if and only if x is greater than y. Now another point, that is log x base y is equal to log x, that is here, and log y base is y. Whatever base is here, you also write here. So that is looks like here. If base e here, if base e also. If base a here, it comes to a here, some base. So that is a base conversion method. Now log x base is equal to ln x, that is natural logarithm. Log x base 10, that is log x, which is equal to common logarithm. Now algebraic function, a function which can be generated by a variable by a finite number of algebraic operations such as addition, subtraction, multiplication, division, square root, etc. is called algebraic function, like polynomial function, rational function, etc. Means x to the power 5 plus 1 into 2x plus 1 whole to the power 3. This is one example of algebraic function. Now transcendental function. All functions which are not algebraic are called transcendental function. Means a trigonometry function, okay, inverse trigonometry function, okay, exponential function, logarithmic function, irrational power function. These are all transcendental function. Odd and even function. A function fx is said to be odd function if f of minus x is equal to minus fx, for x is belongs to domain of f. Means fx is equal to x is one example. That means if you put in place of x minus x, that is comes to, means looks like this, minus x which is equal to minus x, that is a minus of fx. So it is a odd function. A function fx is said to be even function if f of minus x is equal to fx for all x belong to domain of. Means f of x is equal to x square. That means if you think about the question, that means minus x whole square which is equal to x square, that is equal to fx. So fx is a even function. Here fx is equal to cos x, also a even function. Now take one example, that is a function. Take another g of x function fx plus f of minus x by 2. H of x function that is equal to fx minus f of minus x is by 2. So if you put in place of x, that is minus x, that is f of minus x plus f of minus x by 2, that is comes to f of minus x plus f of x by 2, which is equal to g of x. So g of x is a even function. Similarly, h of minus x is equal to f of minus x minus f of minus x divided by 2. That is f of minus x minus f of x by 2. If you take common, that it comes to minus fx minus f of minus x whole divided by 2. That is minus h of x. So that's why h of x is an odd function. That means if you add, now here f of x is equal to g of x plus h of x. Means a function, this is f of x, this is even function, odd function, this is even function, this is odd function. That means every function can be written as the sum of odd and even function. Now periodic function. A function f of x is said to be periodic function if f x plus k is equal to fx for k is constant, where k is not equal to 0. Where k is also called period or periodicity. Example, f of x is equal to sin x. X is equal to x plus 2 pi, that is sin x plus 2 pi, that is sin x, which is equal to fx. That means 2 pi is a period here. If you think about f of x plus k is equal to fx, then f of ax plus b का period k by a होगा. That means whatever multiplication is there, means f of ax plus b का period कितना होगा ना, k by a. Similarly, f of x by a plus b का period कितना होगा, that is a k. Whatever division you multiply it, whatever multiplication you divide it. That is these are the periodic function. So then what is the characteristics function or indicator function? That means if f of x is equal to, okay, that is 1 when x is belongs to the given function, given domain, and it is not belongs to given domain, that is equal to 0. Okay, please subscribe the channel and you like the channel and you get always update video. Thank you.